Welcome to MySQL webinar series from jpassion.com. This is our 8th webinar, and today's topic is performance. So let's start with the presentation. So these are the 4 major topics that we are going to cover in this presentation: query cache, indexing, and explain feature, and slow query log. So let's talk about query cache. So what is query cache? It's a cache where the text of a select statement and its response, the result of it, is saved. So if an identical select statement is repeated by the same client or a different client, the server will take a look at this query cache, and if there is a match, it will use the result from that cache. So this query cache is shared among sessions, meaning multiple clients can take advantage of the cache once cache contains a particular select statement and its result. The reason for using query cache is obvious, and especially is quite useful in an environment where you have tables that do not change that often. And the server receives the same request over and over from multiple clients. And this is in fact typical situation for many web servers that generate dynamic pages based on the data from a database content, meaning database content do not change, and mostly the request is coming from the clients for read operation. So query cache, when a table is changed, then the relevant entries in the query cache is discarded. So this is to prevent the cache reflecting wrong data, or in other words, prevent the query cache from being stale. By the way, the query statement is case sensitive. So select with a capital letter from person is different from select small letters from person. So result of this one are the same, but as far as query cache is concerned, these two are considered different. So MySQL maintains some system variables reflecting various statistical data on this query cache. So query cache size variable specifies the amount of memory allocated for caching, and as a default it is set to 0, which means query cache is not enabled as a default. Now cache type, query cache type can be one of the 3 values. If it is 0 or off, that means query caching is turned off. If it is 1, then query caching is turned on. If it is 2 or demand, then query caching is done on demand basis, and we'll see examples of that in a few minutes. As a default, it's going to be on, but the cache size is 0. So in a sense, it is like a caching is off as a default. Query cache limit maximum result set size. So result sets larger than this cache limit will not be cached. So if you want to see all query cache related variables, you say show variables like, and then query cache pattern, and then you will see the values of these variables. Here query cache type is on, that means it is on, query caching is on, and query cache size is 1 million bytes. Now how the query cache is working is reflected with runtime counter variables. So cache insert, query cache insert is basically total number of times queries are cached. So every time a query is cached, this counter will be incremented by 1. Cache queries in cache represent current number of queries that are present in query cache. And you can actually reset it to 0. Okay. And cache hits, basically number of times queries are hit. So of course, higher number of this value reflects that cache is being used quite effectively. So these are runtime counter variables. If you want to see those values, you say show status like and qcache pattern. So for example, let's say you perform a select query statement here, query operation here, and then you are going to see, suppose your query is turned on, then you can see it will be cached. So you will see qcache insert is going to be incremented by 1. And at that point, there will be 1 query in cache. So you can see these 2 variables are incremented by 1. Now, if you perform the same query statement, then you will see query hits is going to be incremented by 1. Selective caching is used when query cache type is on demand. So as we learned before, one of the type of cache type is on demand. So when you select on demand cache type, then you have to specifically specify whether you want caching or not. So in this case, if you want this select statement to be cached, and you have to say select SQL no cache. Yeah, actually no cache means you do not want this one to be cached. If you want this select statement to be cached, then you say SQL cache right after select statement. Then it will be cached. Alright, so let's do our first exercise. So this is basically query caching the exercise. So we start already MySQL and then we start MySQL client. So this is join table without so this is join table with index. So basically we are performing some query operations. So let's try this. So here we created a table. We created the department table, we created employee table, and these 2 tables are interrelated through the foreign key. And then we have populated department table, and then we have populated employee table. And so let's just run that script. Alright, so we have created 2 tables and populated those 2 tables. Now let's see the query cache for now. So for now you can see query cache is on, but the cache size is 0. That means there is not going to be any cache. There is not going to be any query caching practically. So this is the same thing as having this one as off. Okay. And in terms of runtime counters, they should be all 0 because nothing has been cached yet. Okay. All right. So now we are going to so we just saw this query cache variables. It is actually query size is 0, so practically query caching is kind of the not being enabled. All right, so we are going to perform select operation here after we created these 2 tables, and again you are not going to see any change in runtime counters because there is no caching. Okay, these are all 0. So now we are going to increase cache size to 1 million bytes. So now we are going to start the caching. So we are going to change query caching size to 1 million bytes instead of 0 byte. Okay. Now, if I take a look at the query cache variables, now you can see the query size is 1 million bytes, and because cache type is on, from this point on, caching will be enabled. Okay. All right, so now let's just have this one here. So now let's try to perform query operation, another select statement. Now this time, if we take a look at the query cache variables, we now see number of insert is 1, meaning one query statement is inserted into this cache, and there is one query in cache. So this, when you reset the cache, then this value will be 0. Okay, even though this insert will be staying the same. All right, now execute another same query. So, but for now there is no hits. Okay, now if we perform the same select statement, okay, then let's repeat. Let's take a look at these variables. Now you can see this hit is incremented by 1. And if you perform one more time, then of course this will get incremented. So, oops. So this number of hits is incremented to 2. Okay. All right. So, and so that's what we have seen. And if we perform another different query statement, so let's try to perform different query statement, and this will be cached. So we are going to see this insert, number of inserts will be incremented to 2. Okay. Let's now take a look at the query variables. Now you can see the insert is 2. Okay. And yeah, so that's basically what we have done. Okay, and the number of queries in cache is incremented by 1 as well. Now, if you flush the cache, you can, if you want to flush the cache, you say reset query cache. Okay. Now, if you take a look at the query variables, you can see the number of queries in cache is 0, while the number of insert is still remaining to be still 2. Okay. Now, if we actually perform at this point another select statement, then you are going to see, as expected, number of inserts is going to be incremented by 1, even though it's the same query result before, and then the number of queries in cache, the number of the number of queries present in cache is incremented by 1, in this case to 1. Okay. All right. So that's basically what we have done. 1.5 is performing selective cache. So here we are going to show status. Yes, yeah. So this is what we have done, and here, in this case, is no cache. And yeah, so this is actually working even though, you know, this selective caching works when you are enabled with the caching. Okay, so it works both on demand cases and on case. Okay, so here is no cache. So even if you actually perform the same operation, in this case 1, yeah, actually it's different. Okay, yeah, so I'm going to actually use this lab documentation. So observe. This is probably something that we have cached before. Oh, I'm sorry. Yeah, this is actually brand new one, and it's not going to be actually cached because you say no cache. Okay, so if you actually take a look at the number of queries in cache, is still remaining to 1. Okay, and so if we change this one to Well, actually, I'm going to just copy this one. So same thing, but this time we want to cache. In this case, number of queries in the cache is going to be incremented by 1. So this time is 2. Okay. All right. And you can turn off query caching by setting caching type to off. Okay. And then you can see the type variable now reflects off. Okay. And you can reset all the variables values, and then we can see the values again. Actually, runtime counter. Okay, so the number of queries in cache is 0. And here, even if we perform some select statement, okay, you are going to see nothing is being changed, okay, because we turned off the cache. All right, so that's pretty much regarding query caching. So let's move on to the next topic, indexing. Indexing is probably the most powerful tool that any database server supports in terms of performance enhancement. So what is and why indexing? You can think of indexing as logically a separate table that contains sorted values of a column. And in fact, you can have indexing for each of your columns of a table. So you could have multiple indexes for a table. And the reason indexing is powerful in terms of performance enhancement is because it prevents full table scan. So without indexing, full table might have to be scanned to find a match because you don't know whether that is in fact a row that contains a particular value until you actually read every the value. But having indexed table, you can see whether a particular value is there or not, okay? Because every value is in fact in sorted manner. And inserting or deleting a row from index column is more efficient. Again, if you try to delete a row using, for example, like a where clause, you don't have to actually scan the whole table to find it whether there is in fact a row that actually matches that value. Instead, you can use index column and you can find whether there is in fact a row that matches the value for deleting or inserting. Indexing is actually quite powerful, even more powerful when you are doing queries involving joins on multiple tables. In fact, most of the queries actually involve multiple tables. So by having indexing, you are going to improve the performance quite drastically. So in a single table, the number of values you need to examine per column is the number of rows in a table. So if you have 10 rows in a table, and if you want to find a value, then you just have to take a look at 10 rows. However, in joint operation, you are dealing with the multiple tables, and the number of combinations that you have to actually take a look is exponentially increasing. Okay, so basically, it's a Cartesian product number of read that you have to do. So I'm going to actually use that one. I'm going to explain that one more time using an example in a few minutes. So in MySQL, indexing is used in various places. As I mentioned before, when you have a where clause, that's where the indexing could be used to find whether there is a row that matches the value in where, or rows that match rows in other tables while performing joins. So when performing join query, again, indexed table, the indexed columns are going to be very much useful. Also, queries that use mini and max functions. Again, you can find out minimum and max numbers, max values from the indexed column rather than scanning again whole columns. MySQL often use indexes to perform sorting and grouping operations quickly for order by and group by clauses. So these order by and group by actually require some sorted values. So by having the indexed column, it's going to be a lot quicker. So example query. So this is the example query that explains